10.2, special pairs of angles. We should be on page 479. Page 479. In example 1, we're learning about adjacent angles and how to identify them. The first thing you need to know is what an adjacent angle is. So you need to write this in your notes. Adjacent angles share a common side and vertex and do not overlap. What does this mean? The common side is the line. Okay, so the line that you see, the lines that you see, those are considered my sides. Then the vertex is that midpoint. Okay, so they have to share a common vertex as well. And then overlapping means that they're basically just not going over each other. So they meet at a very specific point. They don't cross that to overlap. I'll give you a minute to kind of sketch this, so I'll pause the recording and then we'll go over identifying the adjacent angles. So when I look for adjacent angles, I'm looking for angles that share a common side, like angles 1 and 2. Angles 1 and 2 share a common line. They are supplementary. That's another thing about adjacent angles. They're always going to be supplementary angles. Okay? So one of my pairs of adjacent angles are angle 1 and angle 2. What? Hold on. Not sure what I did there. Okay, another pair of adjacent angles would be angles 1 and 4. Angles 1 and 4, because again, they share the common side and the common midpoint, and they're supplementary. So angles 1 and 4. Another pair of adjacent angles would be 4 and 3. You tell me the fourth one. On your papers, write it down. It is going to be angles 2 and 3 because, again, they share the common side and common vertex, and they are supplementary. So adjacent angles are basically next to each other. They're supplementary. They share the common side. Now, in example 2, we're dealing with vertical angles. Vertical angles are opposite each other. Okay, so adjacent angles are basically next to each other, sharing a common side. Vertical angles are opposite each other. And when two lines intersect, they form vertical angles. Now, if it is a straight line, vertical angles will be congruent. What does congruent mean? The same. It means that they're the same measure. Vertical angles are the same measure. So go ahead and write this definition and diagram down, and we'll answer this question. So, given that definition, if angle 1 is 75 degrees, what is the measure of angle 3? Willie? Trinity?
When you subtract it by the complementary,
Tyreek?
75 degrees.
75 degrees. What did we just say in the definition? Vertical angles are congruent. If they're opposite each other and the two lines are really straight lines and they're intersecting, the vertical angles are congruent. Okay? So if angle 1 is 75, angle 3 is 75. Now let me ask you this. What would be the measure of angle 4? And why? What would be the measure of angle 4 and why? The measure of angle 4 is 105 degrees because the two angles are adjacent supplementary angles. All right. Now moving on to example 3. In example 3, we're talking about parallel perpendicular lines and corresponding angles. All right, so I'll give you a minute to copy this down, and then we will go over some different parts of this slide. Okay, think of a plane as a flat surface that doesn't have an end. Okay, so just because it has borders, it doesn't mean that it ends there. Now, parallel lines are two lines on the same plane, listening, that never intersect with each other. All right, so let's name these lines. So on your notes, I want you to name these lines. We'll name them M and N. All right, so the symbol for parallel lines is two vertical lines. So I can write, if I wanted you to show that these two lines are parallel, you can write it, you'll use parentheses, M is parallel to N. Line M is parallel to line N. With perpendicular lines, a perpendicular set of lines are two lines in the same plane that do intersect. Even if they don't intersect in the plane, if they're heading towards each other, they eventually will intersect. So that's what we call perpendicular. Perpendicular lines do intersect in the same plane, but parallel lines don't. Okay, so the symbol for perpendicular line is that's too thin. Let's do that. All right, is a vertical line and then a horizontal line connecting. Okay, so if I wanted to show that these two lines are perpendicular, I need to first label the lines A and B, and I could say that A is perpendicular. Go a little bit farther. Come on. Is perpendicular to B. All right? And that is where we will end for part 1 of 10.2.